Okay. So I stopped and started the recording just in case the recording is also corrupted. So there'll be 2 video files for this lecture. All right. Game engines. They're a software foundation on which games are created. Physics, graphics, audio, input. All these, you often hear the word engine afterwards. So what do you think engine means in this case? Yes?
We have code that makes the game world and the interactions within it. So like an engine provides that code for physics, graphics, audio code.
Yeah, in the case of a game engine, right? But each one of these, like physics engines, graphics engines, these are things that have a little bit of domain expertise to do something interesting in a sphere, in an area. We'll get more into what engines are, but game engines are interesting because they're engines of engines, as you were describing. Now, engine programmers. They implement game engines, and this is actually, there's a very sophisticated game engines book, How to Create Your Own Game Engine in C++, made by UC Davis alum. This is a picture from that book. This is the high-level architecture of a game engine in their eyes. And the game engines that engine programmers implement support many games. It used to be, back in the day, well before my day, that games were synonymous with their engine. You made a game, it was making the entire apparatus around the game. Physics, sound, whatever you got. Then game development studios got bigger, more games were made by individual people, and they started, as computer scientists do, looking at commonalities between their code bases and separating off those common code structures, code functionality, into libraries, into externalized, shareable, performant code bits. Eventually, those got sophisticated and turned into game engines. So since you have the slides, this is the reference to the Game Engine Architecture book. And I know you can't read this now, but when you look through the slides, they're already posted on Canvas. You can look at this in more detail if you care to. So a generalized view. Games, in the common mind of a lot of players, really are the systems. Right? They're the things you do. They are like a platformer game where you're hopping from platform to platform and picking up power-ups. They are card games where you are placing and playing cards. There are things like Slay the Spire, where you have a deck builder along with a little bit of procedural traversal of a space. They are things like tabletop games, D&D. They are sets of systems that allow for play. So games and game systems are more broad than the digital incarnation of games. They go analog, digital, metaverse, everything. So let's put a finer notion on gameplay programming. We've talked about a lot of the programming tasks. We've talked about the basic bits of what games are made of at a high level. What makes gameplay programming special or different? Makes it worthy for the topic of a class? It's a type of development. Game development is a broad umbrella. Lots of things are covered by it. Lots of programmers. Lots of people that work with engines. So the engine programmer is also usually considered a game developer, broadly. There's tooling. There's analytics and back-end programmers. There's technical artists, which is one of my favorite roles, other than gameplay programming. There are so many of these roles that fall under developer. It's almost, there are too many to list. But here's a few. Basically, you can take any of these roles and put programmer behind it, because now we have these very large development teams where each person can specialize in one of these areas, or maybe even subdivided even more. The color coding stance. The purple is engine, or typically engine things. Green, assets. Orange, design. Blue, systems. So I colored gameplay programmer blue because if you follow these arrows here, you can make some inferences, right? So first we have this includer here. Gameplay programmers, as their basic tool set, their basic things they configure, their building blocks, are things that the AI or things that the engine gives them, and assets. So they're responsible for taking the engine, the assets, and writing code, writing scripts, combining aspects, combining affordances that the engine gives them, along with the assets that they have available to make these gameplay systems, like inventory systems, NPCs, crafting, vehicles, skills, horse gameplay designs, gameplay patterns. All of these are things that make a game. But the game is specified by the things designers make. Level designers, combat designers, horse designers, crafting designers, narrative designers. All of those provide constraints, an additional set of constraints for the gameplay programmer. They are the edicts that the gameplay programmer, the missives the gameplay programmer has to follow. So in order to fulfill the designs given by the designers, the gameplay programmer uses programming knowledge, scripting, etc., plus what the engine provides, plus the assets to make these things a reality in a game. And the reason I put the extra arrows here is because this is an iterative loop. You will be doing, as a gameplay programmer, you'll be making these things, usually prototypes, alpha versions. They'll be put into a game. People will play them, play test them. The designers will reflect over how well they work and update. And the gameplay programmer will have to include those new updates. So this is really a high-level diagram of what this class is about, the gameplay programmer. We make the things that make the game go. These systems, the mechanics. We help engineer with the designers, the dynamics. It's important also to say, since we're pretty inclusive, we built a positive picture. Now let's build a subtractive picture. Added a picture and subtractive picture. What is it not? What it is not. So there we go, like in English. It is not game engine programming. We are not making network stacks as gameplay programmers. As gameplay programmers, we are not handling the intricacies of the graphics hardware of the PlayStation 5. We're not game scripting. Although we often use programming scripting languages, scripting is typically a more lightweight, easier to understand and use version of game systems that a gameplay programmer makes for designers to use, such as the relationship and traits editor in the Sims series. They have a whole bunch of Sims designers, Sims character designers. The programmers in that game spend a lot of time making the tooling and the higher level, more holistic management algorithms to handle whatever the designers could throw at them in their scripting language. Designers also are usually not responsible directly for asset creation, although a gameplay programmer could be responsible for a procedural content generation system, particle effects, like create assets, modular gun creation systems like in CS:GO. They are not game designers, although they talk a lot with game designers. Often the distinction can get fairly fuzzy with all of these. Game design, gameplay programmers, it's not settled. This is an unfolding field. So when I made this first craft of this class about 5 years ago, this is a term just burgeoning in the game design space. Now you'll actually see jobs for gameplay programmers. So this is a trend that's building. It is not settled yet, but it is growing. It's becoming more solid. And it's not solely programming. There's a lot of reading, a lot of sub-design work, a lot of altering of game design documents, a lot of architecting involved in gameplay programming. So it's something that stresses a lot of parts of your brain. So those of you who are very programming minded and haven't maybe sampled output more broadly. This could be a difficult class for you. But for those of you who have always like tinkered in games or are artists or designed things on the side, this could be a class that unlocks things for you. I'm looking forward to seeing what happens. So, in the space of iteration here, iterative design, let's refine what it is again. It's code that directly impacts the gameplay experience. It's code that people will touch. It's code that players will interact with very directly. It's applied software engineering. The engineering design patterns are very useful here. Implemented design. So you have to take the things that the non-technical designers give you and make a technical system out of it. You have to say, yes, this is a traveling salesperson problem. This is intractable. Sorry, redesign. Right? So this is why computer scientists are good at this. They can actually tell you when what you're doing is not something that can really exist. You do not have the computational capacity to handle the thing you want. It is a technical weaving of assets, design, narrative, all the things we talked about into a playable experience. You are sort of like the tip of the spear going into new territory, I don't want to complete that metaphor. A lot of it feels like software engineering plus design plus user experience. And maybe like the old user experience when it was aspirational, as opposed to current user experience in tech culture, which is about optimizing clicks and attention, time on platform, those sorts of things. This is about enabling the player to do what they want to do, not just keep their eyeballs glued to your screen. This is my working definition of gameplay programming. The implementation of computational media that creates an experience that is faithful to the design as set by game designers through the creation of gameplay systems, player interfaces, and game interactivity. I'm not going to expect you to memorize this. But reading through this, there are some things here. First, implementation is straight off, right? Leading with a core task of computational media. Games, VR experiences. Basically, what programming does is it gives you the ability to make a computational thing, a thing that does some computation. Well, we're using that in media. And it creates an experience. So experience right here brings in the player. It's something that is experienced by someone else. That is faithful to the design as set by game designers. Right? Another core task. You have to implement a design as a gameplay programmer. Through the creation of gameplay systems, player interfaces, and game interactivity. Right, so we unpack this definition a bit. So now maybe all these parts make sense given what I've been talking about for the last half hour. So for this class, you can see gameplay programming as this. We are centering the gameplay programming task. And all the things that will come our way are game design, the game engines, narrative design, game testing, game assets, many places monetization. Pardon me. All of these come into our world, touch us, impact us. We need to triage in our own sphere of gameplay programming. Common roles are implementing gameplay systems. Picking up power-ups, hit points, magic points, spell slots, equipment, all the things you've probably seen a bunch of times. Inventory, shield damage and regeneration, like Halo-style shields. Card draw mechanics, like in Hearthstone. Combat systems, like in any number of fighting games, from Final Fight to the Street Fighter series. Create and tune basic game motion. This is an important one, particularly when you're starting off, like learning how to make things move. Interactivity, not just making an animation curve that is played in Blender, but animations that are live. What does a good jump feel like, and how, like in Mario, you can like change your momentum in midair. How do you make that feel good? How do you make a double jump? How do you make a jump boost? Right? How do you make a jump dash? All of these are basic game motion techniques. We'll talk about them. We may talk about them too much. Design and implement user interfaces. From HUDs showing health and ammo to journeys. Almost HUDless HUD. Heads up interface. Or we want to integrate runtime working systems of several. We want to integrate the runtime workings of several game systems. So, how many of you have played an MMORPG? Which ones?
I played WoW for 12 years.
WoW for 12 years. So that means what? You started around.
I was 4 years old.
Oh well, okay. that's an early entry into the genre.
Yep.
Excellent. Talking about screen time early. What about Final Fantasy 14? Terra? Ultima? That's way too old. What other MMOs have you been playing? You got a lot of hands. Who else?
There was one time that I played a bit of ESO.
Oh, ESO, yeah. Eve. All right. So these are sort of like one of the strong embodiments of the runtime working of several game systems, from trading to combat to experience to social interaction to navigation, fast travel, flight systems, you name it, MMO's got it. And what I kind of like about gameplay programming is probably one of the reasons I like focusing on it is it often is associated with game AI tasks. Interacting with characters. Interacting with procedurally generated worlds. Have you ever played like one of the Borderlands games or Destiny? Any of the Destiny series, 1 or 2? Yeah, yeah. Procedurally generated all over the place. Guns. Sometimes, well, I guess not in Destiny. There's not a lot of enemy spawn locations that are procedural. But you also are interacting with smart events out in the world. You're interacting with bosses that will react to your placement, positioning, and tactics in a lot of cases. So we often border or parameterize AI tasks. I consider the AI designers gameplay programmers. Design specifications really help us out. The gameplay programmers, while they border design and they have to be fluent in reading design artifacts like this, they are not creating these for the most part. Now, good teams will be integrated, and you'll have the gameplay programmer in the room when a lot of design discussions are happening, so they're up to speed. But this is quite an influential diagram. This is the ability, the high-level ability system of DHAC. DHAC was the code name for Diablo 3, which also set the stage for Diablo 4, which was also very influential to the combat system of Warcraft 3. And Warcraft 3's map editor and the basic affordances that laid out gave us a little game called Dota. And from Dota came Dota, Dota 2, League of Legends. So these documents are sort of like core specifiers for incredibly influential games today. Direct attacks, like melee shots, instant ranged attacks, propelled attacks such as an arrow, lobbed attacks like grenades, homing attacks, AoE circles, novas, PB AoEs, conal attacks, area beam shots. You can see where skill shots come from here, right? I guess these are area attacks. The nova is a spreading area attack, an expanding ring. Right? I'm sure many of you have played many of these mechanics. How many of you have played at least one of these mechanics in a game? Yeah, I expect a lot of hands. All right. So the designer that actually designed these documents is Stone LeGrande. Stonetronics.com. We're going to feature some of his work in class. One of my favorite designers. Worked with Blizzard, worked with EA, worked with Spore. Geez, what didn't Stone work with that was influential? So we take those specifications and we make them into gameplay systems. Right? Look at the game feel of that. It feels good. It's one of my favorite game feels right here. Crescendo. I know these are an older version of League of Legends, but you can see how those design specifications are directly created from a specification like these. Right, so next attack deals bonus damage. Attacks in League of Legends are these instant ranged attacks in the case of Sona, right? These right here. I guess I have a mouse, that's a little easier. These right here. And then you have Crescendo. Which one's Crescendo? Area beam attack, right? Right here. One more time. The days. What's this? Journey. Why do you think I'm showing you this? What's special about this screenshot in Journey?
Isn't it pushing to the world?
Does it show you your end goal top left?
Yes, it does. And the end goal is almost always visible in Journey. When it's not, is a point of tension when you're in the ruins, right? What else? Yeah?
So we have another title separated by the fact that there's a display of something using your controller.
Right? This is about the only time you're going to see something non-diegetic in Journey. By non-diegetic, I mean something not of the game's fictional world. Right? They're showing you how to do something in the game with the controller. Kyle, how often do you think this would happen in Journey? Do you get a sense of that? Like, what percentage of the game would you be seeing a controller?
Not a lot.
Not a lot. Sub 1%, I'd say.
Yeah.
Yeah. But it's there, and it's all you need. User interface design. Teach you how to do it, and it becomes intuitive if it's done well. Does anyone recognize this?
Total War.
Exactly, which one?
3 Kingdoms.
3 Kingdoms, exactly. So what is it? What is this?
Technical tree.
It's the tech tree, right? So what do you think I'm showing this to you?
Different color and 5 different attributes.
Yeah, so each one of these little white spheres is a point in the tech tree that gives you some sort of bonus after you accrue enough. What's the resource that opens the tech tree? Edicts. It's some law-based term.
You can recruit different kinds of soldiers.
Yeah, exactly. You unlock different soldiers. You unlock different bonuses for economy or farm or the number of trade contracts, this sort of thing, as you go through the skill tree. Now, skill trees are interesting game artifacts, right? They unlock the gameplay mechanics for you. This is a gameplay system. There's a lot of choice here in how you progress. And you have the sphere of economy, you have the sphere of law, you have the sphere of agriculture, a sphere of military, war, if I remember correctly, something like that. And the deeper you go down the tree, the more powerful the bonuses you give. So you can either spread out and become a generalist, or really probably the better thing to do is to specialize and become really potent when you hit the end of a tree. So that's a gameplay decision that players have to make, that you as a gameplay programmer have to implement and support. This also is very pretty and diegetic, right? It is a watercolor painting in and of that historical fiction. The Reform Tree. So, I just wanted to give you a sense of possibility, a sense of things that gameplay programmers have made. Now let's look at what the possibilities are, what the practical things a gameplay programmer does. What skills do you need as a gameplay programmer? We talked about what you do, how you, like what you have to work with, what your constraints are, but what are your actual skills? So here is your gameplay programmer tech tree. Not complete. There's plenty of expansions that can be added to this. You have all the slides and everything too. Feel free to take pictures, but you have all this available. First is the design branch, the design subtree, where you have to be fluent in types of game systems, in game design theory, in game design literacy, and game literacy in general, including game history, design frames, how to analyze things with mechanics, dynamics, and aesthetics. What is human-centered interactions? In your game systems, what are the sister interrelations? How do they connect with each other? What are genres or typical loadouts for games? What are game platforms? What's platform studies? How do games adapt to platforms? What is this concept of platform adaptation? All these are very important things for a gameplay programmer to be fluent in. And we're going to focus on some user experience here, since the gameplay programmer is responsible for things that touch the gameplay experience very directly, that craft it. So things like interaction design, game juice, which we will have a segment on, graphic design, interaction loops, which is a very interactive, this is a very computational media game concept, with core loops, loop interactions, loop evaluations. Technical art, including things like procedural content generation or particle effects. And we also have software engineering, right, where you have to be familiar with how game engines basically work, how to use them, what are the spectrums of engines available to you. You have to be familiar with things like design patterns, like the command pattern, the pub sub pattern, observer pattern in factories, all of which we'll cover in this class. This is part of the CodeCraft sub-branch, term I coined. I don't know if anyone else uses CodeCraft. I think it's fun. What are code standards? How do you review code? How do you analyze code? What are style guides, and how do you use them to make better code? What does debugging look like? Logging, exposure debugging, unit testing, profiling. All these are things you need that are bread and butter of programming in general and software engineering. How do you work with teams? What's teamwork methodology? How do you communicate with each other? How do you have to use Agile, unfortunately? Versioning systems. Git, CVS, Perforce, SVN. Do people use any others anymore? Is that a complete set now? Bitbucket, but the Bitbucket's Git-based, right?
Yeah.
Yeah. So I guess you could amend the tech tree for platforms in which versioning control systems live. Code style and best practices. What's bad about this code? I'll give everyone just a minute, and I'll call on you first. Your second. Just give it just another bit here. What do you got?
Personal preference, but bracket at the end of the line. C#, come on.
Fair. Absolutely. And that's style guide dependent, right?
Yeah.
It depends on whether you're using Microsoft C# style guide, using Unity style C# guide, or using some DevHouse C# style guide. Like Unity recently released a book about crafting your own style guide for your game, right? So they haven't done the step of, here's the style guide for a platform. They're like, whatever, we don't care. There are too many conflicts, roll your own. Yes?
I think it's for pre-5, it should be all the uppercase.
Where?
Pre-5, yeah. Because in C#, it's usually the uppercase.
Yeah, so there is a class called prefab. In this case, prefab is coming in.
Yeah, I know, but it should be the uppercase, like, yeah, because C# usually uses the uppercase variables.
It does in some cases. It doesn't generally in arguments.
Yeah, and another is that for the bracket, you should go to another line, like
Like right here,
Yeah,
going down to
yeah.
here. Yeah,
Yeah.
exactly. Yeah. I lost order. Was it? Who was? Can you all help me disambiguate? You're first. Go ahead.
Okay. This, maybe it might have been cut off or something, but I feel like there should be something before preload function.
Yeah,
Like
this is a
like
snippet from a larger class. Yeah.
Well, I was gonna say like, but did this include like a purpose input output, like a description of what this method is going to do in a broad sense?
Documentation. Thank you.
Because like I know like I could maybe glean like with preloading prefab. I look at this and like, what is it supposed to do exactly? Like, why would I want to use it?
Exactly. Yep. Contextualization, documentation, very important. Who is next? Or you? I don't. We'll get to you both.
I guess I'll go.
Yeah. Go ahead and. Go ahead.
For spawn and despawn, they're both functions. I feel like they should use a consistent spacing instead of like.
Yeah.
There's a space behind the.
Right? There's not a space here, there's a space
There
here.
isn't.
Deconsistent, there's a space here, and there's not a space here. Right? Inconsistent spacing. Lead to reading errors. Makes it just harder to read and parse. It takes a moment longer to read it. Yes?
Oh, that was the same comment I had.
Excellent, good job. Yeah.
Does it need to be in two loops? And also, like, you're making an array of game objects, but you already have the game object in the scope of that first loop. So you can just do spawn and then despawn right after. Weird.
Ooh. I mean, that is taking one type of optimization, like repeating less code, but it also introduces a major problem. Does anyone know what the major problem is? It has to do with the size of the array. And that problem exists down here and would exist up here if you put this code in this for loop as well. Okay, the gist is you should not be changing the elements in an array, like deleting, removing, or adding elements in an array inside of a for loop where the invariant of the for loop depends on its size. You're asking for null errors. You're asking for segfaults. You're asking for files not found. You're asking to go right over the end of that array. Particularly since we are only, we're even just bringing in a number that we just, are arbitrarily using as the size of the array, right? When you despawn them all, what if spawn failed? What if spawn returned a null? You're despawning a bunch of nulls. We're not doing any error checking on the values inside of the array while we're using them. There's all sorts of stuff wrong with this code, right? So we have style. Where the curly braces go, where these spaces are, how things are named, what capitalization schemes do we use. And then we have best practices, like not changing the array that you are dynamically inside of a for loop that you are iterating over. Right? All sorts of stuff. So that's one type of best practice and style. Next we have design patterns. Who has used design patterns? Who's taken Nita's class? Right? So you know these design patterns? Kind of. Well, we'll be putting them into use in this class. So, I mean, those of you who were here this morning heard me rant about this a little bit. How many of you feel like there's a space? So when you go out there in the world and you want to learn how to program, there's just infinite amounts of tutorials on how to do Hello World, right? And then there's a lot of really high-end material that may be beyond the technical understanding of most computer scientists out there. More advanced talks about how very technical systems work, or that include a lot of math knowledge. Well, what about in between? Where do you go to go from like maybe where you are as a junior or senior programmer, an undergraduate degree, to becoming that master? Like, where's that learning material in between? Do you feel like this is a whole? It's because it kind of is. It's because a lot of people don't focus on the next steps. So after you learn programming, basics of programming, what do you learn next? Algorithms? Nope, good.
I feel like you're kind of expected to do your own project and like learn all of that, I guess.
Well, we don't expect you to learn the programming on your own. We don't bring you in here and be like, okay,
Yeah, I mean like after.
there's pedagogical content out there for all levels.
Yeah, like I'd say like a lot of people like ask like, oh, how do I learn like program better? Like most people will be like, oh, like do a project. It's like that doesn't really tell me anything.
Exactly. I mean, that is the prevailing wisdom, right? It's like saying it takes all the pedagogy and all the learning and puts it into an unstructured play area. But there's structure there to learn. You can do both. Most classes involve, the known, the formal parts, the structured parts of what you need to learn, and then they say go do it. And by using it, by utilizing it, by building your own structures with the things you know, you can reinforce what you know. And then they tell you the next step of thing to learn. But once you get out of into the junior program world, there's like, oh, do projects and you'll learn better. Right? That's not how the world has to be. One of the next steps you can go to, past algorithms and data structures, are actually things like design patterns. This is the interstitial space between basic programming, algorithms and data structures, things like, red-black trees, queues, vectors, those things that you learn and you spend a lot of time on, and then you're learning upper division classes. These design patterns sort of take that algorithms, data structures level as a substrate and build the next level of computational abstraction above it. Command queues. Pub submodels. Event-based programming. All of these are ways of using your existing computer science knowledge to build larger, better things in more reliable ways. So that's why we're going to focus them on this class. They actually provide a very convenient substrate for us to make gameplay systems. And once you know how these larger areas of code work together in these design patterns, then it's much easier to conceptualize software architectures. It's much easier to write that integrated system that takes some information from a large language model, integrates it with a GPS database. So once you start thinking and know the abstraction layers, you're learning the implicit patterns of how these things interact. It's much easier to conceptualize them, hook them together, and to do reasonable things with the information flow in a very large system. So this gives you that way to go from junior programmer to senior programmer. Right? This is one way of helping climb that hill. And a lot of this really revolves around making sense of larger code artifacts, decoupling, actually decreasing the complexity of complex things to make it easier for a human brain to understand. You have a layer of reliability under you. Much like assembly became a layer above zeros and ones, and then low-level programming became abstraction level above assembly, and higher-level programming language became an abstraction level above C. Games use these a lot, and we're going to use them in our exercises. This is the design pattern, the Gang of Four book, the sort of canonical book that you have free access to, online access to from the library link down below. All right, let's read the syllabus. Let's talk about the structure of the course. We have just a few minutes left, and I'll open it up for questions after we this up. This is a long day. We have a whole another lecture we could have stuffed in here too. All right, so the basics of the class. This is the grade layout for the class. We have a group programming project that is the focus of the course. I want to give you at least 5 weeks to work in a team to make a game. We'll talk about this a lot. It goes from design. We'll have check-ins. We'll have team pods that will meet and talk over your progress, so we can have some intermediate grading. We're going to have our finals slot is actually our play festival, where you can show off and play your games to everyone else in the class, and we'll bring in other game design faculty and other folks that are interested to come and check out your work. No test. Exercises are the other important part of the class. These are where you can be individually assessed on your ability to perform in the course's content and not be sort of like munged into the larger milieu of a team. We typically have 4 exercises in this class. We may have 5. Sometimes we have 3, depending on just how crazy the world gets. So what we do is we take the number of exercises we have, divide 45 by that number, and that's how many points each exercise is worth. Participation is worth 10 points. And we'll talk about it. Participation is in 2 categories, attendance and participation. And we have a physical code-based method for handling that, which we'll talk about right now. Code-based participation mechanism. We'll get more information on that soon. We'll talk about it. Basically, we hand you codes that have an alphanumeric key on them. You put the alphanumeric key in a Google form, and that'll get added to your attendance score. So instead of doing personal attendance or just letting you go open loop, we'll hand you a little code. We'll make a little game out of it. And participation will be the same. Go to office hours, ask good questions, rock it during class, speak up a lot on Discord, go watch some of the guest speakers and ask them good questions. All these are worth participation codes. And participation is worth 5% of your grade. Roughly in the past, each code that you get is worth 1 of those points. Course communication, so major announcements we made in Canvas and be mirrored on Discord. Discord is where a lot of our communication will happen. For rapid communication to virtual meetings, they'll all be there. Ask your questions on Discord first. Why do I do that? Well, it's because if you have the question, chances are someone else does too. Obviously, if it's personal and private, go to the email first. First, Kyle is the first point of contact, then it escalates to me if necessary. You can typically email us both so we both see it. Is a good protocol. The exercises will be given via GitHub Classroom. Have you used GitHub Classroom before? Have you used GitHub before? I'm assuming the majority of people by this point have used GitHub, right? So GitHub Classroom is just a mechanism to give you each a repository for your assignment, for your exercises, that is individual to you, spun off from a template project, which is mine. And then you have your own repository to dump your results into. And so basically, this class, turning in your project, simple. You put a commit onto your assigned GitHub Classroom repository on master, and we grade the master. We'll pull them when they're due and grade them. No complicated fussery about it. The exercises. So the exercises are in this format. We give you a base form of a Unity project with a description of a task to complete. The task will be about game systems. Most of the time with software design patterns. I think all of these have software design patterns. One of them is a little more implicit, but the rest feature them directly. And each will involve a peer code review. We'll talk about that in just a moment. Your group project. You can design a game of your own, given a criteria. Usually I give the TA the privilege of picking the topic, the overall jam topic of the games for the quarter, which you can optionally use, but we will have some fun chatting about with you, maybe even participation codes if you directly address the topic. Maybe we can even have diversifiers. We'll see. So usually we have around 5 people per team. And we have a defined set of roles and sub-roles for you to help in some way get some experience in this role-based gameplay programming process. And we'll look at what those mean in a while. You'll make a design document. I'm actually going to give out, I think, some prospectuses this year. A lot of people just defaulted to games that they weren't very passionate about. So I have some games that I have in the pocket, some designs that I think would be fun and appropriate for class that you can use if you want. All right. You also, we'll do peer review on your group projects. You'll want to make a website and a press kit. So one of the roles will be a website and press kit person. And we'll make a class gallery. Usually people use Itch.io. Get it on Itch. And so, once again, we have a festival, not a fight. We'll be using the Unity game engine. The news yesterday was so bad. Like, a quarter of the company got laid off last night. It was really, really grim news. In the future, we almost moved to something else this quarter. If I would have known this was going to happen in the corner, we probably would have moved to some other engine. Probably Godot, given this class. But we are using Unity. We are set on that course now. There's no way to refactor everything. It is a C# based system with a component-driven game engine, or the component-driven architecture. So component is a software engineering pattern. You're going to learn one just by, or learn how to use one. Maybe not all of the concepts behind it, but you'll be using it in every Unity project you make. It's also an industry standard game engine. Lots of games are made in Unity that are AAA, that are indie games. It's a very prevalent game engine. But the course isn't actually about learning Unity. It's about gameplay programming. It's about the skills that you'll be using in all sorts of engines past just Unity. So the homework for this week is actually a set of self-study materials, learning just the basics of Unity, how the editor works, how the basic programming stuff works. So I guess your goal for this week, it's not a graded goal, but it'll be necessary for you to do your first assignment, which I'll hand out on Friday, and it'll be the Friday thereafter, is to become familiar with the Unity environment, get it installed, get your environment up and running, learn the basics of C#, given that you already are, all of you are seniors. You should be able to pick up a new language pretty readily. And there are a few ways we have to do this. Okay, then we don't need to cover this stuff. Let me just move right to the browser real quick. There we go. Wait, where's my version of it? There we are. All right, so going to the syllabus, course description, you can talk about exercises. So this first week, overview of the course, game engines, anatomy of game engine development, the command pattern, the reading is Salin and Zimmerman. Discussion will probably actually be about exercise 1. Your assignment due dates, your assignments are getting started with Unity materials. And what does that look like? So let's go down to this class. So this is our preparing for project section. This is the roughly 5-day regimen of 2 or 3 hours of material per day to get you bootstrapped with Unity. I have handpicked these tutorials, although this is getting incredibly hard now. Unity is really not doing well on upkeeping its materials, and it's putting all of its pedagogic stuff into these experience pathways, which are infused with Unity sales stuff. So this path still exists. Creating your Unity student account. We're going to give out a getting started document to show you how to make your Unity account, link it to get a nice student account so you get good versions of everything. We're going to show you how to make a GitHub account, although most of you already have it, and then how to get to the student version of that, which is actually a really good deal. You get tons of cool stuff with GitHub's student package. So getting started with that, installing Unity Hub, and then installing your version of the Unity engine that we'll use. Start creating, explaining the editor layout, some tutorials from Microsoft about C#. This one's probably the more important one, the Rollerball tutorial. Classic Unity learning right here. Many a Unity expert started with Rollerball. And then the scripting overview documentation. And then there are 2 follow-along tutorials about beginner scripting, intermediate scripting. These are, I think, between an hour and 2 each. And then finally, there's a long Unity tips tutorial. Please still exist. There we are. And it's actually 4 hours long, so you actually can sort of pick the ones you want to do from here. These are all more advanced tips. So that's your assignment for the first week, is getting familiar with Unity and the environment of the system. Our alternative way to do that is spending time with Kyle. And Kyle's Let's Play Along Learn Unity session. Kyle will send out information about when that will take place. And we'll decide whether you want to record it or not. That sort of thing. We'll post my office hours and you can learn there as well. So we're not grading any of this, right? But you need to take agency and learn like the basics of this environment. And we have a variety of ways to help you. Just let us help you. Or help yourself. Okay. Illidan Storm Rage. Going through here, some things I want to highlight while we have 5 minutes left. So I did de-highlight in Young 184, because we'll probably be doing virtual discussion sections. We have 0 holidays that intersect with our class time this quarter. It's a little strange. I know, right? Our final examination period, festival period, is Thursday, March 21st at 3:30. We'll probably book a room other than this to do it in. Course description, feel free to check it out. Materials. So here we are, for this class, using Unity version 2022.3.16 F1. But this will be, the F1 is the only 16 release, or should be. You can download it directly here at this website in Windows, OS X, ARM, Linux. Well, if you have the Unity Hub, you can just put this URI into your URL bar, and it will open up Unity Hub and prompt you to directly install this exact version. You can download Unity Hub here. So that's how you'll interface with the tutorial that Kyle will be releasing about getting started with your Unity account. Great, so that's stuff for now. I'll just grab Discord over here. I don't want to stream Discord or record Discord. Lots of people joined. Welcome. Lots of people joined. Welcome. So in the welcome screen, you want to read all this and make sure that you agree with all this. You want to, before you click the button, you want to change your server nickname to be your real name, because that's the policy we have to operate under. And then you'll click the comment right here, and you'll automatically get the Student of Gameplay Programmer role, which means you will see this category right here, which has basic course information, course announcements, all the discussion from like 5 years of history of the class, and where we'll be meeting, like our meeting stage, and a few chat rooms for us to use. All right. I wanted to highlight on the exercises, since you'll be getting those soon. 70% of an exercise's points will be about how well you completed the exercise. 30% of the points will be how well you peer review one of your peers' submissions. So how does this work? Well, this Friday, I'll assign exercise 1. Next Friday, you will turn in exercise 1. The Monday thereafter, we will give you assignments on who you are peer reviewing. That Friday, you will turn in a peer review. We have a template-based peer review process because I'm sure many of you haven't peer reviewed before. Before then, we'll talk about peer reviewing. We'll talk about code style. We'll talk about best practices. And so you'll have to analyze someone else's code for those things, including how well they achieve the objectives of the assignment. Right? So we bake in this more peer interactive process into this. I think it's really important when you're talking about the level of software engineering we're talking about, when you're talking about games, complicated artifacts, that you see each other's code and you comment on it. Keep it professional. We've had some people be mean in the past, and that's SJC worthy. It's about the only time I send people to SJC. It's when they're very cruel to each other. So that's the basic structure of these assignments. I do reserve the right to give quizzes if people are not interacting with class. I don't plan on doing it. I haven't done it in like 2 or 3 years. You all seem like a fine group of people. I don't need to torture you. We talked about participation and attendance. So you can find, here's participation code policy as I described. Here's the attendance algorithm. It's usually on one line of code, but I have it quite big so you all can read it in the back. You can look at our weekly schedule. All of the assignments are already posted. Hey, here's exercise 1. Here's assignment 2. Here's assignment 3. We have a bunch of materials also in this GitHub repository. Let's get back to home. We have a peer review folder, which we'll be going over this a bit, where we have the templates for peer review for the first 4 exercises. But we also have graded examples of peer reviews for you to look at and base your own on. We have a set of projects that are demos that we'll look at in class. These are Unity projects, including, valuably, the gitignore file that you'll want to put in your own Unity projects so that you don't check in all of the intermediate files that Unity puts in your folders. We have some images. These will be useful later. They're basically where the repository for images that I use to explain things or that go into some of the exercises. We have some resources, including some flyers. One of the better things is the Unity class hierarchy, which you'll see. This is one of the only visualizations of the Unity class hierarchy breakdown that you'll find. So it's pretty valuable. It's hard to find that visualized for some reason. All right, and we have a lot of MD files. The syllabus is readme.md. We have assets, which has a list of free game assets, which I'll probably have to recurate. Most of these should still work though, for use in your game and game projects. We have, right up on the component design pattern. We have description of your game projects put into the class, including how they're graded, how you submit them, the team member roles, producer, user interface, movement physics, animation visuals, input, game logic, these sorts of things. So you can take a look at what roles you'll be taking in your final project. Here is a GitHub Classroom small recipe for you to use. Get that far. Whenever I get sick or have to go to a conference, the first thing I'll do is assign the JuiceMD assignment, which I really love. Like, there's a sequence of design conversations and gameplay system implementing conversations about game juice, particularly featuring Celeste. Project document template. This is what you'll be turning in for your final project, along with the code. A style guide, and talk about game engines, description of game engines. So this is the basic way to navigate this document. The last things I'll say, and if you have to leave, go right ahead. I know we're 1 minute over. We just had a lot to cover today. You can look over the weekly schedule. Notice at the end, I tend to have the last 2 or 3 weeks tailored to what you all want to learn. There's a lot of resources here to learn more about learning the basics of Unity, learning the basics of C#. You're welcome. Learning about game design documents, game feel, production cycles, development teams, Scrum, Git. There's a lot of curated materials in the syllabus for you to delve into at your leisure. Attendance policy, code of academic conduct, technology classroom policy, social media policy. I'm also going to add an AI use in the classroom policy, use of generative AI tools in the class. I don't use them a lot. You're responsible for learning. I think it's about all we need to cover right now. We'll cover more on Thursday. I'm happy to take any questions if you have them. If not, have a great day.